Hey there, and welcome to the Deep Dive. Today we're going to be talking about something that is pretty fascinating to me personally. We're going to be diving into the world of the quantified self and how machine learning can be used to unlock some of the secrets hiding in all that data.
Sounds exciting.
Yeah, I mean, you know all those fitness trackers and apps we use, they're spitting out mountains of data about us. But what can we actually do with all that info?
Well, that's what we're here to find out.
Exactly. This deep dive was inspired by you listeners. We got a ton of questions about how machine learning can be used to make sense of personal data, especially when it comes to health and wellness.
Yeah, there's a lot of potential there.
Right. We're talking about potentially using this data to improve our health, our habits, even our well-being.
No kidding. It's like having a digital mirror that reflects back not just what we look like, but how we actually live.
I like that, a digital mirror. So
Yeah.
before we dive in, let's quickly define what we mean by quantified self. Basically, it's the idea of tracking various aspects of your daily life using technology.
Right. Think steps, heart rate, sleep, even mood, all that juicy data.
Juicy is right. I gotta admit, when I first saw how much data my fitness tracker collects, I was blown away. Steps, heart rate, sleep. It's kind of creepy.
Yeah, I know what you mean. It's like Big Brother, but for your own good. Maybe.
Right. But that brings us back to our core question. Can machine learning help us make sense of this data deluge and actually use it to improve our lives?
That's the million-dollar question, and it's not an easy one to answer. The truth is, applying machine learning to this kind of data comes with its own set of challenges. For starters, the data itself can be quite messy.
Messy how? Give me an example.
Well, take your GPS data, for example. Sometimes it makes it look like you're running faster than a Ferrari.
Huh. Yeah, pretty sure I haven't broken any land speed records lately.
Exactly. That's what we mean by noisy data. It's full of errors and inconsistencies that we need to clean up. And then there's the issue of missing data. You don't wear your tracker 24/7, right?
Guilty as charged. I usually take it off when I sleep. Speaking of sleep, don't even get me started on the accuracy of sleep tracking.
I hear you. But that's another challenge. And on top of all that, this data comes in sequences. Your heart rate over time, your steps throughout the day, it's not just a bunch of random numbers.
So how do we even begin to make sense of this data jigsaw puzzle? I know you mentioned machine learning, but honestly, it all sounds a bit like science fiction to me.
It's actually more science than fiction these days. Machine learning is all about training algorithms to find patterns in data and make predictions. Think of it like teaching a dog a new trick. You show it examples, reward good behavior, and eventually it learns.
Okay, so we're training these digital dogs to sniff out patterns in our data. Got it.
Exactly. Now, there are different training methods, each with its pros and cons.
Like what?
Well, one is called supervised learning. We give the algorithm labeled data, like here's your heart rate, accelerometer data, and labels that say walking, running, or sitting.
Okay, I see. So we give it a cheat sheet and say, figure out what these patterns mean, and then go find them in the rest of the data.
Precisely. But sometimes we don't have those labels. That's where unsupervised learning comes in. It's like giving the algorithm that puzzle without the picture on the box.
So it has to figure out the patterns and group similar data points together all on its own. That's pretty impressive.
It is. And it can reveal hidden patterns we might never have noticed otherwise.
That's wild. Okay, I'm starting to get the hang of this. We gather the data, and then we unleash our digital bloodhounds to sniff out those hidden patterns. What happens next?
Well, that's where we turn this raw data into something meaningful. And that's where feature engineering comes in. It's like taking all those puzzle pieces and figuring out how they fit together.
I'm intrigued. Tell me more.
Imagine we want to understand your running form. We can use your accelerometer data to calculate the frequency of your steps.
Frequency, like how often my feet hit the ground.
Exactly. We can analyze that frequency using something called a Fourier transform. It's a bit like separating white light into a rainbow of colors.
Okay, so we're breaking down the signal to see its individual components.
Right, and those components can tell us something about your running style. We can use them as features for our machine learning algorithms. And we can do this with all sorts of data, your heart rate, your sleep patterns, even your social media posts.
Wow. It's like we're extracting all these hidden clues from the data to give the algorithms more to work with. But how do we actually use those clues to make predictions about things like activity level, mood, or even potential health risks? That's where the real magic happens, right?
You got it. And that's where those different types of algorithms we discussed, supervised, unsupervised, semi-supervised, and reinforcement learning come into play. Each one has its own strengths and weaknesses, depending on what we're trying to achieve. It's like we have this whole arsenal of algorithms, each with its own strengths and weaknesses. Some are like bloodhounds, sniffing out subtle patterns, while others are more like sheepdogs, herding similar data points into clusters.
So which algorithm is best for, say, predicting my activity level? I'm curious to know if I'm actually getting enough exercise.
For that, a support vector machine, or SVM, might be a good choice. It's like drawing a line in the sand between different activities. On one side, we have walking, on the other, running. The algorithm learns to place that line in just the right spot based on your data.
Okay, so it's creating boundaries between different activities based on the patterns of my data. What if we want to go deeper and understand how my mood affects my exercise habits? Can we use algorithms for that too?
Absolutely. For that, we might use a decision tree, which is a bit like a flowchart. Imagine it asking, is your mood positive? If yes, then maybe it predicts you're more likely to go for a run. If no, it might predict you're more likely to skip the gym.
So it's a series of yes or no questions that lead to a prediction. That's pretty cool. But we're talking about combining data from my fitness tracker, my phone, and even my social media. Isn't that a bit much?
It's definitely a lot of data, but each piece adds a different layer to the puzzle. Your phone usage might reveal how much time you spend sitting versus moving. Your social media posts could offer clues about your mood and social interactions. By combining all of this, we can get a more holistic picture of your life and how different factors influence your behavior.
It's amazing to think that we can glean so much information from these seemingly unrelated pieces of data. But I have to admit, I'm a little uneasy about all this data collection. What about privacy?
That's an important concern. After all, this is your personal data. The good news is that there are ways to protect your privacy while still unlocking the insights from this data.
Oh, I'm all ears. How do we strike that balance?
One approach is to anonymize the data. That means removing any personally identifiable information like your name or location.
So it's like scrubbing the data clean of any obvious identifiers. But wouldn't that make it harder to analyze?
Not necessarily. We can still use anonymized data to find patterns and make predictions. And there are even more advanced techniques like federated learning where the algorithms learn from your data without ever actually seeing it.
Wait, how is that even possible?
Imagine the algorithm is like a chef who wants to learn your secret recipe. With federated learning, the chef never gets to see your actual recipe. Instead, they send you little snippets of instructions like add a pinch of salt or stir for 5 minutes. You follow those instructions on your own data and then send back the results. The chef can then use those results to improve their overall recipe without ever knowing your exact ingredients.
That's incredible. So my data stays on my device, but the algorithm can still learn from it. That's a relief. But even with these privacy safeguards in place, there's still something a bit unsettling about having all this data about me floating around.
I understand. It's a new frontier, and it's natural to feel apprehensive. The key is to be aware of the potential risks and benefits, and to make informed choices about how your data is used.
Okay, so knowledge is power. But even with all this incredible technology, it still comes down to us, right? We have to decide how to use these insights, how to interpret them, and how to make changes in our lives based on what we learn. It's not just about letting the algorithms call the shots.
You're absolutely right. Technology is a tool. It can help us understand ourselves better, identify areas for improvement, and even nudge us in the right direction. But ultimately, it's up to each of us to take ownership of our health and well-being.
So it's like having a super smart personal trainer who can analyze our every move and offer personalized advice. But we're still the ones who have to lace up our shoes and hit the pavement. Or maybe hit the snooze button.
Exactly. And that's why it's so important to understand not only what these algorithms can do, but also what their limitations are. They can provide valuable insights, but they're not a substitute for human judgment, critical thinking, and good old-fashioned self-awareness.
I'm hearing a lot of emphasis on taking responsibility for our own health and well-being. It's not about handing over control to the algorithms, but about using them as a guide on our journey of self-discovery.
Precisely. The Quantified Self movement is all about empowering individuals to take control of their health. And machine learning can be a powerful ally in that quest. But like any powerful tool, it needs to be used wisely and ethically.
Okay, so we've talked about the challenges of this messy data and all the different ways that machine learning can help us make sense of it all. But I keep coming back to this question of like, where do we go from here? What's the big picture?
Well, that's the million-dollar question, isn't it? We're really just scratching the surface when it comes to the quantified self and machine learning. I mean, think about it. We've mostly focused on data from fitness trackers and phones. But what if we could integrate that with like data from your medical records, your genetic information, even environmental data like air quality or pollen counts.
Whoa. We'd be talking about a seriously holistic view of our health, like having a whole team of doctors and scientists and personal trainers working together just to keep you healthy.
Exactly. And imagine the possibilities for personalized medicine. We could use your data to predict your risk of developing certain diseases and tailor treatments specifically for you.
That's pretty amazing to think about. It's like the future of healthcare is right around the corner. But it also kind of makes me think about all the things that could go wrong. Like what happens to all this data, who owns it, who has access to it, all that kind of stuff.
Those are super important questions. We need to be thinking about data security, privacy, and ethical considerations every step of the way. We don't want to create a future where our data is used against us.
I think a lot of people are worried about that, especially with all the headlines about data breaches and algorithms gone wild.
Yeah, I get it. It's a valid concern. But I do think we can find a way to balance innovation with responsibility.
So how do we do that?
I think transparency is key. Companies and researchers need to be upfront about what data they're collecting, how they're using it, and what steps they're taking to protect user privacy. And individuals need to be empowered to make informed choices about how their data is used.
So it's all about striking that balance between progress and protection.
Exactly. It's a delicate dance, but it's one we need to learn to do well. The stakes are pretty high.
Well said. So as we wrap up this deep dive, I'm left with a sense of awe and a bit of healthy skepticism. The possibilities are truly incredible, but so are the potential risks. It's up to all of us to shape the future of the quantified self and make sure it's a future we can all be proud of. Thanks for joining us on this journey. And a special thanks to you listeners for sending in all those amazing questions that inspired this deep dive. We'll be back next time with another fascinating topic. Until then, keep exploring, keep questioning, and keep diving deep.